Okay, in order to be able to assess and analyze rational functions, you're going to need to use these 7 steps. This is a conclusive 7-step procedure that will allow you to do almost everything when it comes to assessing rational functions. So right now, you should pause the video and write down this entire procedure. Write the whole thing down. We're going to be using it in an example that we're going to do right after you write down all of these steps. Okay, so what we're going to do here is we're going to identify all that stuff that's in, and we're going to use those 7 steps. Okay, we're going to identify the domain, the intercepts, the coordinates of any holes. There's one hole in this, and all asymptotes. That means vertical asymptotes and horizontal asymptotes. And when it comes to intercepts, it's going to be x-intercepts and y-intercepts. So here's our function f of x. You should write it down. Do this along with me in your notes. Write it down and pause when you need to pause. The first thing we're going to do is we're going to identify the zeros of the denominator. And we know, based on step 1, that the domain is going to be all real numbers except those zeros. So thankfully, our denominator is already in factored form, so we're going to take each one at a time. X plus 1, set it equal to 0. We're going to take 2x minus 3, set it equal to 0, and take x minus 3 and set that equal to 0. And when we solve this, we're going to subtract 1 from both sides, and we get one of our zeros of the denominator is x equals -1. If we were to plug -1 in here, we would get 0. 0 times this is 0 times this is 0. And so if we plug in -1 for all these x's, there will be a 0 in the denominator. Same thing with 3 over 2. If we solve 2x minus 3, we add 3 to both sides. We divide by 2, and we get 3 over 2. So if we were to plug 3 over 2 in here, we would get 0, and it would make the whole denominator 0. Same thing with x minus 3. If we add 3 here and add 3 here, we get x equals 3. If we plug 3 in here, we would get a 0, and the whole denominator would be 0. So our domain is going to be from -infinity to +infinity, but we're going to leave out -1. We're going to leave out 3 over 2. And we're going to leave out 3. So that's why we have to do these unions, so that we leave out the numbers that make the denominator 0, because the denominator cannot equal 0. All right, so let's now move on to step 2 here. Step 2 says to plug the zeros of the denominator into the numerator. Okay, well, what are we plugging it into? We're going to plug it into 3x cubed minus x squared minus 13x plus 30. So we're going to plug -1 in here, and in here, and in here, and when we do, we get 32. Then we're going to plug in 3 over 2. And when we plug in 3 over 2 for all, or sorry, just the numerator, for all the x's in the numerator, we get 21 over 8. And then when we plug 3 in the numerator in each of the x's, we actually get 0. Okay? And the rule goes like this. If the numerator is not 0, and when we plug in -1 and 3 over 2, we do not get 0. If the numerator is not 0, then that x value, so -1 and 3 over 2, that number, the x value, is a vertical asymptote. Okay, so we've identified the domain, and now we've found 2 vertical asymptotes. And that's all there is. So there's a vertical asymptote at x equals -1, and that's how we write a vertical asymptote. And at x equals 3 over 2. And that's how we write the second vertical asymptote. Vertical asymptotes are vertical lines, and so they're defined by x equals. So x equals -1 and x equals 3 over 2. Okay? But when we plugged in 3, we got a 0. And if the numerator equals 0 when we plug the number in, that number represents what's called a hole on the graph. Okay? So there's a hole on f of x at x equals 3. And we need to find out the y coordinate of that hole. So that's what we're going to do next. Next thing we're going to do is we're going to cancel the whole factor from the numerator and the denominator. Then we're going to plug in the whole x value, which is 3, to get the y value for the whole. You may have to watch this part of the video a couple times. So the whole x value is x equals 3, and so the whole factor is x minus 3. Remember that if we plug a number into a factor, it should equal 0. So if we plug this 3 into x minus 3, we get 3 minus 3, and that's 0. Okay? Then what we want to do is we want to divide x minus 3 out of the numerator. Well, the numerator is 3x cubed minus x 8x squared minus 13x plus 30. And to divide x minus 3 out of this, we're going to use synthetic division. So we're going to put a 3 in the half box. We're going to do 3, negative 8, negative 13, and 30. Okay? And so we're going to bring down the 3. 3 times 3 is 9. 9 and negative 8 is 1. 1 times 3 is 3. 3 and negative 13 is negative 10. Negative 10 times 3 is negative 30, plus 30 is 0. And we should get a remainder of 0 because we know that when we plug in 3 to the numerator, we get 0. So the remainder theorem says that the remainder should be 0. So now what we're going to do is this, 3, 1, and negative 10 are our new coefficients for the numerator, 3x squared plus x minus 10. And you can see that right over here, okay? So the reduced function after x minus 3 is removed from the numerator and the denominator is this. Okay, so we have the two factors. We canceled x minus 3, so now we only have x plus 1 and 2x minus 3. And then we have the numerator with x minus 3 divided out, 3x squared plus x minus 10. Then what we're going to do is we're going to plug 3 in all of these x's here and find out what our y value is. Okay, so we plug a 3 in here and here and here and here. We wind up getting 20 in the numerator and 12 in the denominator, 20 over 12. And if we divide the numerator by 4, we get 5. If we divide the denominator by 4, we get 3. And so the y value of the whole is 5 over 3. So there is a hole in f of x at the coordinates 3 and 5 over 3. So far we have identified the domain, the vertical asymptotes, okay, and the coordinates of the hole. So we're doing really well. Moving on to step 4. Now what we're going to do is we're going to convert the numerator and the denominator into standard form. Well, the numerator is already in standard form right here. We just need to expand this. We need to distribute. We need to multiply these two factors by each other. And when we do, we get 2x squared minus x minus 3. Okay? Now it's converted. And now all we have to do is compare the degree of the numerator to the degree of the denominator. So this is 3x to the second power, and the denominator is 2x to the second power. So the degree of the numerator is 2, and the degree of the denominator is also 2. So the numerator degree is 2, and so is the denominator degree, so they are equal. And if you look at our list, look under number 5, part B says, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is equal to y equals the lead coefficient of the numerator, which is 3, and the over divided by the lead coefficient of the denominator, which is 2. So it's this 3 right here divided by this 2. It's just the front two numbers, 3 over 2, and so there's a horizontal asymptote at y equals 3 over 2. And so we've identified the horizontal asymptote. Now we just need the y-intercept and the x-intercepts. Well, step 6 says that the ratio of the numerator constant, which is negative 10, over the denominator constant, which is negative 3, is the y-intercept. So it's negative 10 over negative 3. But negative 10 over negative 3, we can cancel the negatives and we just get 10 over 3. So the y-intercept is at 0, 10 over 3. Okay, almost done. And now step 7, the last step, this one's probably the longest one. Set the numerator equal to 0. So we're going to take this 3x squared plus x minus 10. Now we're going to set it equal to 0 and solve for all x solutions. These are the x-intercepts. Now believe it or not, this is factorable, but it's a challenging factoring process, so I'm going to go ahead and use the quadratic formula instead. A is 3, B is 1, and C is negative 10. So I'm going to use the quadratic formula. I'm going to do negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. And so I wind up with negative 1 plus or minus the square root of 1 plus 120 over 6. 1 plus 120 is 121, and the square root of 121 is 11. And so this now becomes negative 1 plus or minus 11 over 6. Now we're going to split it up into the two solutions, negative 1 plus 11 and negative 1 minus 11. So here are the two solutions. Negative 1 plus 11 is 10 over 6. And 10 over 6 can be reduced to 5 over 3 because 10 divided by 2 is 5 and 6 divided by 2 is 3. Now we'll do the minus. Negative 1 minus 11 is negative 12. So we have negative 12 over 6, and negative 12 divided by 6 is negative 2. So these are our x-intercepts, 5 over 3 and negative 2. And so we're going to write them out as coordinates. The x-intercepts are 5 over 3, comma 0, and negative 2, comma 0. And that is it. I recommend that you watch this video maybe 1 or 2 more times so you can get comfortable with these 7 steps, and I will try to do some more examples that include other kinds of horizontal asymptotes and also slant asymptotes.